let's apply object-oriented design to solve this problem. From the problem description, we have two outstanding nouns, circle and rectangle. So those two could be classes. For circle class responsibility, first properties or states are location and radius. For rectangle, property or states are locations, width and height. And then the common behavior of a circle is to compute the area. Behavior of a rectangle is also compute the area. And another behavior of a circle and rectangle should be, it should be drawn. It should be rendered on the screen. And then we can identify another property of a circle, that is color. So rectangle has also a color property. So using that, let's draw a UML diagram, a class diagram. It's a circle and rectangle. So from draw.io, let's create a new diagram, and then blank diagram. Let's create and the location. I have designated a folder for that, and here is the location. I'm going to store, save the files. So we are going to use UML. First, let's draw a diagram for circle. Let's make it bigger. Circle class, and then states or property. We expect a location. So X location, let me use a float number. You could choose a double as well, but as you use a float, there's some precautions you need to take. And then there is a Y as location. Let me extend the size of the field. And then we have also identified the color of the shape there. And then in terms of behavior, public, let's get area and float, and then render. We are going to provide graphics to graphics to 2D object graphics 2D, and void. So that's what you expect as a behavior. So that's things about circle we have identified, and then let's do that similarly for rectangle. Then rectangle has a X location, Y location, and the color. And let me make it bigger. And in terms of a behavior of a rectangle, we expect get area, float, and then render G2 graphics 2D void. That's what we expect as a behavior of the rectangle there. So we have identified the classes, we have identified the responsibilities, states, and behavior. And the next step is find the relationship between two classes or more. So before we find the relationships, we are going to factor out the common things between two or more. Let me correct here. So this should be minus. So between two classes, a circle and rectangle, we find many common things there. So for a circle, XY color, rectangle, XY color, those are common things. Also, circle has another property I forgot to add, that is radius. Similarly, for rectangle, I should have width and height. That's a property of a rectangle as well. So common things are many things. So we can factor them out and then create a non-existing, just a conceptual class there. So let's name it as a shape, as common things. And then this could be abstract class or interface. Let me delete this. Abstract class is if common things include member variables. If common things include behavior method only, then it could be interface. But if common things include member variable, then it has to be abstract class. Recall that in the interface, you cannot have an instance member. So because of that, you can choose to have abstract class or interface. Now we have common things are X, Y, and color, so this should be abstract class. So let's move the common things. Those common things are copy and paste. So X, Y, and color, those are common things. So let's delete X, Y, and color from circle and rectangle. So take those out. X, Y, and color out. That's common things. So in the circle, radius is left over, rectangle width and height left over. As to the behavior, get area and the render are common. So let's move that to, it's not working. Copy again and paste there. So we move those methods to the shape. However, we need to make a decision here. In shape, can you compute the area? Answer should be no, because unless we know the specific type, circle or rectangle, we are unable to compute the get area. Then we need to have a get area in circle as well, but we are going to override the method in shape. So member variables, you can simply move there and then delete from those classes. But however, member methods, you can check that. Can you render directly from shape? No, we cannot do that. Then we are going to have a render method in circle as well, and then we are going to override. So we are going to use a polymorphism for doing so. So we have factored out the common things and create new just the conceptual class. This is going to be abstract class because it has data members. Now class relationship. As we factor out, it automatically becomes a super class and subclass. So we can draw arrow that represent extends. That is this one. So here, so we are going to have a circle and shape. Let's break line like this. So in UML diagram, the professional style is always a horizontal and the vertical line only. It's a running diagonally. It's not very professional one. So I have done that. And then for rectangle and shape, we also have a same relationship there. So extend from rectangle to shape is a superclass subclass relationship. So that's inheritance. Between circle and rectangle, this is not inheritance. This is not composition or aggregation. This is not a dependency. So just this is the whole about everything about the class relationships. So we have created abstract class shape, and then we have identified inheritance relationships among those. And based on this, now we are ready to write the code. So you can save the current drawing, and then you can open up later after that.